it's equally important to note that we don't know everything about the effects of artificial drainage on water. And specifically, we don't know about the effects of tiling. And it's an important statement to make because when people think of drainage, they think of tiling. And part of the reason they think that is because that's what's going in right now, is miles and miles and miles and miles of pattern tiling. But the way that drainage alters the landscape and the way that pattern tiling alters the landscape can be a little different, and we need to understand more about those before we can really say how they're changing hydrology. The important part about tiling and hydrology fits together pretty neatly. We put drainage on the landscape for the purpose of reducing water residence time. Sometimes we reduce water residence time to 0. That's called getting rid of a wetland and draining it. Other times we have low spots in the field like you have out there, and it stays soggy and wet and either drowns out the crop or can't get into it with equipment. So in that case, we may put in pattern tiling with a surface inlet, we may put in just a tile main, or they could put in even a ditch through there. But whatever the case is, we take water that used to sit on the landscape for a significant amount of time, maybe 2 weeks, and we only allow it to sit there for 2 or 3 days. Nobody argues with that's what drainage does. And we know that it's effective in doing that. It's what's allowed us to farm larger fields and be more productive with the crops. Drainage changes water residence time. Drainage is underground and invisible, which when you drive across southern Minnesota, most of the landscape has some form of artificial drainage on it. You just can't see a lot of it. And the other invisible process is what happens to that ponded water, which is not ponded there right now because it's gone, is that it used to sit in that ponded area, and some of it would infiltrate slowly into the ground, and a lot of it would evaporate back up into the air. In Minnesota, about 75 to 80% of all the precipitation that falls on the landscape goes back up in the air through evaporation or transpiration. Plants transpire, give out water as part of photosynthesis. 80% of the water that comes down goes back. When we put in drainage, we change the water residence time, and we take a portion of that water that used to evaporate and we quickly move it into the rivers. Drainage can do a lot of different things to the landscape. It can allow it to absorb more rain, the so-called sponge effect. But overall, the largest effect of drainage is to reduce the amount of water that we used to put back to the atmosphere, and instead we're shunting that water to the rivers. That surplus water is increasing the flow in the rivers. It is a consequence of that, and it is undeniable in terms of the direction that it has to move river flow. River flow has to go up as a result of this. The amount that drainage has altered river flow is a question that needs further examination in science. We have some estimations, and we have some conflicting estimations, which we need to continue to work through. But we do know that since 1940, which is when we first started monitoring stream flow in rivers, we know that flows in many rivers in Minnesota, in many rivers in the Minnesota River Basin have doubled.